You know, when you think about the biggest things in the universe, you probably picture like massive galaxies and huge clusters of stars. Right?
Makes sense.
But get this today, we're going to flip that idea completely on its head.
Oh.
We're going on a quest to uncover the biggest thing in the universe, and it's not what you'd expect at all.
Intriguing. I'm ready to have my mind blown.
Buckle up. We've got these really cool excerpts from a YouTube video called What is the Biggest Thing in the Universe?
Okay.
It's by this channel, History of the Universe. And let me tell you, it's going to take us deep into some seriously mind-boggling concepts.
Well, I'm always up for good mind-bending.
Me too. All right. So the big question we're tackling today is this. What is the biggest thing in the universe? And we're not just talking about what.
Right.
We're also going to explore why. Like, why are these cosmic voids so significant? And what do they tell us about the past, present, and future of the universe?
I think what's so fascinating about this topic is that it really challenges our intuition, you know? Like, we automatically think big equals lots of stuff. But today we're going to be looking at these huge regions of space that are actually defined by how empty they are.
It's wild. Like, imagine you walk into a mansion and you're expecting to see all these extravagant rooms. But then someone tells you the biggest room is actually the empty attic.
Huh. I see what you mean. It's not about the stuff inside, it's about the space itself.
Exactly. So let's talk about these cosmic voids. Now, hold on a sec. They're not just empty space, right? Because space is already pretty empty to begin with.
Haha, good point. You're right. Cosmic voids are different. It's not about a complete absence of matter. It's more about these regions where the density of matter is way lower than the average dense universe.
So, like, imagine the universe is a giant cupcake.
Okay, I like where this is going.
And all the matter in the universe is like sprinkles scattered on top.
Gotcha.
These cosmic voids are like someone took a big bite out of the cupcake, leaving behind these huge areas with barely any sprinkles.
Oh, that's a great analogy. So it's not about a complete absence of matter. It's about areas where matter is incredibly sparse.
You got it. And honestly, it's kind of hard to wrap your head around the fact that the biggest things in the universe are basically regions of nothingness, right?
Yeah, it's counterintuitive for sure.
So how did astronomers even stumble upon these voids in the first place?
So picture this. You're an astronomer back in the 1970s mapping galaxies with the technology of the time.
Guy.
You're expecting to find these galaxies scattered pretty evenly across the universe, kind of like a smooth, starry soup.
Yeah.
But then you start noticing these gaps, these patches where there are hardly any galaxies at all.
So they were expecting a smooth soup, and instead they found like Swiss cheese. Wait a minute, were astronomers skeptical at first? Because wouldn't a hole in space be kind of hard to miss?
You'd think so, right. But back then the data was limited and the technology was still pretty basic.
I see.
There was definitely a lot of skepticism in the beginning.
Really?
Oh, yeah. Some astronomers thought there might be errors in the surveys or that they were just seeing patterns where none existed.
I can imagine. It must have been crazy to be one of those astronomers who first spotted these voids, trying to convince everyone else that the most important things they'd found were actually these areas with practically nothing in them.
It must have been quite a challenge. The real turning point came in 1981 when astronomer Robert Kirshner and his team discovered the Boots void.
Boots void?
Yeah. It's one of the largest known voids even today. Its sheer size was mind-blowing, even bigger than any known galaxy or cluster at the time. It was like the void was shouting, hey, look at me, I'm here, I'm real.
Haha, like deal with it.
Huh.
Okay, so now we know these voids exist, but just how big are we talking? I mean, earlier we mentioned superclusters, which are already unbelievably huge. How do voids compare to those?
Well, voids come in different sizes,
Okay.
ranging from tens of millions to billions of light years across.
Wow.
And of course, the biggest ones we call supervoids.
Super void, so like super duper empty.
Exact. And to put things into perspective, the Boots void is estimated to be about 330 million light years in diameter.
330 million light years. Jeez. Can you imagine trying to explain that to someone who complains about their commute? Like, oh yeah, it takes light 330 million years to cross this thing.
Yeah, that would put things into perspective.
Right. And remember, you mentioned earlier that voids have this kind of fractal nature.
I did. What does that even mean?
All right, so picture this. You're exploring this massive cave, right?
Okay.
Inside this huge cave, there are smaller caves. And within those, even tinier caves.
Like a whole cave system.
Exactly. And that's kind of what it's like with voids, a hierarchy of emptiness.
Whoa, yeah.
So even within a void, you'll find these faint galaxies arranged in miniature versions of the cosmic web.
So what we're learning is that even though these voids seem empty, they're actually telling us a lot about how the universe is structured.
They are.
And that brings us to another really cool aspect of these cosmic voids. They're not just sitting there doing nothing. They're actually playing a role in shaping the universe.
They are indeed shaping the universe around them. That's amazing. But how can something that's mostly empty have such a big impact? I mean, it seems counterintuitive.
It does, doesn't it? But think about it this way. As the universe expands, these voids are kind of pushing matter away from them.
Huh?
It's like they're making more space for themselves.
Okay.
And that pushing has this ripple effect on everything around them.
So are the voids like cosmic bullies?
Yeah.
Pushing all the galaxies and clusters out of their way?
That's one way to think about it. But it's not necessarily a bad thing, you know? This pushing actually helps to create the large-scale structure of the universe.
Oh, really?
Yeah, it stretches and thins out those filaments of the cosmic web, causing clusters to drift further apart.
So it's like they're shaping the universe by creating these vast empty spaces.
Yeah.
And those spaces define the boundaries between the areas where matter clusters together.
Exactly. You're getting it. Over billions of years, this process is going to lead to a totally different cosmic landscape. Well, that intricate web of galaxies is going to become more and more fragmented. You'll end up with these isolated islands of matter surrounded by huge oceans of empty.
Whoa. So a universe of lonely islands drifting further and further apart. Huh. It's a beautiful thought, in a way, but also kind of sad, don't you think?
It does make you contemplate the vastness and evolution of the universe. It really does.
Definitely. But here's what I'm wondering. If these voids are so empty, wouldn't they be kind of boring to study?
That's a fair point. But here's the thing. They're not boring at all. In fact, they're like looking back in time.
Wait, what? Hold on. How is that even possible?
Because voids are relatively unevolved. They haven't gone through the same level of complex changes and interactions as the denser parts of the universe. So studying them is like getting a glimpse into the early universe.
Wow.
Like before all the messy stuff of galaxy formation and evolution happened.
Oh, wow. So it's like finding a perfectly preserved fossil that's been hidden away for millions of years.
Exactly. It gives you a direct window into the past. It's incredible.
That is amazing. And because voids are so simple, so clean, they must be ideal for studying some of the biggest mysteries in cosmology, right? Like, what about dark energy?
You got it. Dark energy is a big one. Remember, dark energy is that mysterious force that's driving the universe's expansion.
Right. So why are voids particularly helpful for studying?
Okay. Imagine you're trying to study the current of a river, but you're focusing on the spot where a bunch of leaves and branches are swirling around.
Okay, I'm picturing it.
It's going to be tough to see the underlying flow, right?
For sure.
Well, galaxies and clusters are kind of like that. They're full of all these complex interactions and processes that make it hard to isolate the effects of dark energy.
I see. So the voids are like looking at a calm stretch of the river where you can actually see the current flowing smoothly.
Exactly. They provide this much simpler environment where the subtle effects of dark energy are easier to measure and study.
Okay, I'm starting to get why these empty spaces are so valuable for understanding the universe. It's like they're holding secrets that we can only unlock by looking beyond the bright, shiny objects. But wait a minute. We talked earlier about how the existence of supervoids actually challenges our current understanding of the universe.
Right.
So doesn't that mean there's a chance we're misinterpreting what we're seeing in these voids?
That's a fantastic question. And honestly, it's a debate that's going on right now in cosmology.
Really?
Oh, yeah. Some scientists believe that these supervoids might point to new physics, things we haven't even discovered yet.
Oh, hold on. New physics. Isn't that kind of a big leap? I mean, are we sure we haven't just missed something more obvious?
It's definitely a possibility. But that's what makes science so exciting, right? There's always the potential for these groundbreaking discoveries that could completely change how we understand the universe.
True. Okay, I'll try to keep an open mind. But tell me, how are scientists planning to investigate these voids even further?
Well, there are some incredible new telescopes coming online soon, like the Euclid and the Nancy Grace Roman telescope.
Cool.
And these telescopes are going to be able to map millions of galaxies across huge stretches of the universe, giving us these incredibly detailed maps of the cosmic web, including the void.
Wow, that's amazing. I'm really curious to see what they find. It feels like we're on the verge of something huge here.
It's an exciting time for sure. We're going to have so much more data to work with, allowing us to study the properties of voids with way more precision than ever before.
So it sounds like we're entering a golden age of void research.
I'd say so.
I can't wait to see what secrets these seemingly empty spaces will reveal in the years to come.
Me neither. It's going to be an amazing journey.
Awesome. Well, folks, that's going to wrap up part 1 of our deep dive into cosmic voids. Stick around for part 2, where we'll delve even deeper into the mysteries of these mind-boggling structures.
We'll be right back.
All right, so we've got these giant cosmic voids shaping the universe. But how can something that's mostly empty have such a big impact?
Well, you got to think about it this way, As the universe expands, these voids are essentially pushing matter away from them. It's like they're creating more space for themselves, and that has this ripple effect on everything around them.
So the voids are kind of like cosmic bullies pushing all the galaxies and clusters out of their way?
Haha. Yeah, that's a fun way to put it. But it's not necessarily a bad thing. This pushing actually contributes to the large-scale structure of the universe.
Oh, really? I wouldn't have guessed that.
Yeah, it stretches and thins those filaments of the cosmic web, causing clusters to move further apart over time.
So it's like they're shaping the universe by creating these vast empty spaces that define the boundaries between the areas where matter clusters together.
You got it. Over billions of years, this process is going to create a really different cosmic landscape.
A different landscape? Like how?
Well, that intricate web of galaxies we talked about, it's going to become more and more fragmented, leaving behind these isolated islands of matter surrounded by these huge oceans of emptiness.
Wow, a universe of lonely islands drifting further and further apart. This is a beautiful image in a way, but also kind of sad, don't you think?
It definitely makes you think about the vastness and evolution of the universe.
Yeah.
It's pretty awe-inspiring.
For sure. Okay, so we talked about how these voids are shaping the future of the universe, right?
Yeah.
But you also mentioned earlier that they can offer us a glimpse into its past.
Right, exactly.
But I'm having trouble wrapping my head around that. How can something that's so empty tell us about the early universe?
Because voids are relatively unevolved. You see, they haven't undergone the same level of complex interactions and changes as the denser region of the universe.
Yeah.
Studying them is kind of like looking back in time.
So like time travel.
Not quite time travel, but close. It's like we're getting a glimpse of the universe before all the messiness of galaxy formation and evolution happen.
Oh, so it's like finding a pristine fossil that's been perfectly preserved for billions of years.
Exactly. It gives you a direct window into the past. It's amazing.
That's incredible. And because these voids are so simple, so clean, they must be ideal for studying some of the biggest mysteries in cosmology, like the nature of dark energy, right?
You got it. Dark energy is a huge one. Remember, it's the force that's driving the expansion of the universe.
Right, of course. So why are voids particularly good for studying dark energy?
Okay, so imagine you're trying to study the current of a river, but you're focusing on a spot where there are tons of leaves and branches swirling around.
Okay, I'm picturing it.
It's going to be pretty hard to see the underlying flow, right?
Yeah, definitely.
Well, galaxies and clusters are kind of like that spot in the river. They're full of complex processes and interactions that make it difficult to isolate the effects of dark energy.
Ah, I see. So the voids are like looking at a calm stretch of the river where you can actually see the current flowing smoothly.
Precisely. They provide this much simpler environment where the subtle effects of dark energy can be more easily measured and studied.
Okay, I'm starting to understand how these so-called empty spaces can actually be so valuable for understanding the universe. It's like they're holding secrets that we can only unlock by looking beyond the bright and shiny object. But hold on a sec. We talked earlier about how the existence of supervoids actually challenges our current understanding of the universe, right?
We did.
So doesn't that mean there's a chance we might be misinterpreting what we're seeing in these voids?
That's a great question, and it's something that cosmologists are actively debating right now.
Oh, wow. So there's no clear answer yet.
Not yet. Some scientists believe that the existence of these supervoids could point to new physics, like things we haven't even discovered yet.
Whoa, new physics. That's pretty mind-blowing. Are we sure we haven't just missed something more obvious?
It's always a possibility, but that's the beauty of science. There's always the potential for new discoveries that can completely revolutionize our understanding of the universe.
True. Well, I'll try to keep an open mind. But tell me, how are scientists planning to investigate these voids even further? What are the next steps?
Well, there are some incredible new telescopes coming online soon, like the Euclid and the Nancy Grace Roman Space Telescope.
Those sound familiar.
Yeah, and these telescopes are going to be capable of mapping millions of galaxies across vast distances, giving us incredibly detailed maps of the cosmic web, including the void.
Wow, that's amazing. I'm really curious to see what they find. It feels like we're on the cusp of some major breakthrough.
I think so too. We're going to have so much more data to work with, which will allow us to study the properties of voids with much greater precision than ever before.
So it sounds like we're entering a golden age of void research.
I'd say so. It's a very exciting time to be studying these enigmatic structures.
I'm definitely eager to see what secrets these seemingly empty spaces will reveal in the years to come.
Me too. Who knows what we'll find?
And we're back, ready to wrap up our deep dive into the biggest thing in the universe, which turns out to be mostly nothing.
It really is mind-boggling, isn't it?
It is. It's funny how the things we used to think of as empty and insignificant are now turning out to be some of the most important structures in the cosmos.
It really goes to show how much we still don't know about the universe.
For sure. I mean, we started out this episode thinking about massive galaxies and superclusters, and now we're here talking about these giant cosmic void that are almost completely empty.
Yeah, it's a great reminder that sometimes the most profound discoveries come from the most unexpected places.
Yeah,
You know?
absolutely. So before we go, let's do a quick recap for our listeners just to bring everything together.
Sounds good.
So we learned that cosmic voids are these vast regions of space with super low density.
Right, and it's not that they're completely empty.
Right.
It's more like they contain far less matter than the average density of the universe.
Exactly. And these voids aren't just static spaces either. They're actually expanding and influencing the evolution of the cosmic web around them.
Yeah, they're kind of like these cosmic architects sculpting the large-scale structure of the universe through their emptiness.
It's a cool way to think about it. And of course, as we discussed, these voids are super valuable for scientific research. They offer a glimpse into the early universe and provide a unique environment for studying things like dark energy.
Right, because they're relatively unevolved and so clean.
Yeah, it's like they're full of information just waiting for us to unlock it.
Exactly. And with all these new telescopes coming online soon, we're going to have the tools to study these voids in much greater detail than ever before.
It's pretty exciting to think about all the discoveries that might be waiting for us out there.
Oh, absolutely. We might find evidence of new physics, unlock the secrets of dark energy. Who knows what else?
It's incredible. But before we let our listeners go, I want to leave them with one final thought.
Okay.
If these seemingly empty voids can teach us so much about the universe, imagine what other hidden wonders might be out there just waiting to be discovered.
That's a great question to ponder. I'd say it's a call to keep exploring, keep asking questions, and to never underestimate the power of looking beyond the obvious.
Couldn't have said it better myself. So to our listeners, we say this: keep looking up, keep asking those big questions, and never stop being curious about this amazing universe we live in. And remember, sometimes the most profound insights come from the places we least expect. Thanks for joining us on this deep dive into the biggest thing in the universe. Until next time, keep exploring.
See you next time.